Looks like we have 20 people on, if my screen is telling me it accurately. So why don't we get started? It's 2 o'clock. Thank you everybody for joining us for the Data Explorer launch. My name is Jeff Gladstein. I manage the OOI cyber infrastructure, and I will be doing the introduction today. And Craig Reesian from OSU will be doing the demo, and he will introduce himself at that time. I assume many of you are familiar with OOI, as that's how you got an invitation, but I did still want to talk about it. It's an observing network that delivers real-time data from more than 800 instruments. I think what's really important in this paragraph is that the data is freely available and online for everyone to use. And you can see the locations where we have our moorings. Do note that Southern Ocean Array and Argentine Basin are no longer generating data, but you still can search the data and use it for what we do have. And then I've put the institution managing that particular array next to it. Some facts you may not know about OOI. We have 6 years of data out there now for 89 platforms. As I mentioned, we have over 800 instruments, of which there's greater than 30 different types of instruments out there. We have 72 billion rows of numerical data, so that's quite a bit of data to go through. We service 20 million data requests per month, everything from the very small amount of data requested to plot down to a terabyte of data downloads that maybe include the whole history for an instrument. We do service about 6.2 terabytes of data downloaded monthly. So what you see here is how diverse and deep the collection of data is. The 2 gray squares that you see here, I screenshotted from the Data Explorer tool that you're going to see. And one represents all the instrument types, and the other, all the parameters. And hopefully you can see my mouse, and you'll see some 2 gray boxes here. The numbers in there represent how many of these features we have. So there's 35 instrument types with over 101 different parameters, ranging from CTDs to fluorometers, measuring conductivity, chlorophyll. You have bioacoustic sonar, and you'll see some vent information out there. It's interesting to note that the cabled array has instrumentation on an active volcanic vent, delivering some very interesting data. And I think some of the differences between OOI today and some of the past data collection is that we're constantly observing, we're constantly taking data in from these sites, building a very dense data set, allowing for investigations of episodic or real-time events and long time series, versus maybe some of the past where you have a campaign style data collection, which may represent days, weeks, or months. And by doing this, you can look at how different events affect the oceans. The goal is to collect 20 years of oceanic observations. So why are we here? Why Data Explorer? I've been with the program for a little over 2 years now. And when I first came to OOI, first thing you do is you talk to people to get to understand the program and the technology. And I heard a lot of internal feedback, user stories, and feedback from users themselves that highlighted that the current data portal, what we all call OOINet, may have some issues. Many felt that the interface is not intuitive, data is hard to find, and there is a steep learning curve. People who felt comfortable with OOINet and liked it did have a long period of time in which they had used it. So they had gotten over that steep learning curve. I'd also heard about some missing features, such as being able to view multiple graphs at once, or more robust search capabilities. And then selfishly, managing the technology, we wanted a newer technology stack. to make it more easily supportable. We were finding that support of it to get from point A to point B was taking a little bit more time than we would like. This led us to analysis of alternatives. And simply put, an analysis of alternatives is looking at the marketplace and seeing, is there another solution or technology out there that could better serve us? And the conclusion we came to was A, yes, there was, and B, we wouldn't have to replace all of OOI structure to do this, that it was modular enough that we could plug in another interface. And this led us to select Axiom Data Science as the subawardee to help bring the next generation of data exploration of OOI data. And you can see their mission, understanding of society and environment by increasing accessibility and their capabilities, their profile, and certainly their partnerships. But what really drew us as a panel to select them was their deep experience in oceanographic data and tying it to user interfaces, and a lot of the work that they've done there, as well as their culture. A culture of openness, discussion, and engaging with the user was very attractive for us. And I should note that Brian Stone and Stacy Buckaloo are also on this call video from representing Axiom. I think also very important, I want to highlight here is a development approach, because I want to hear from users out there, and this will be a repeatable process for it. What we did was, the first thing we did is we built a proof of concept. We put OOI data into the core Axiom-based solution that they've used at other sites. We then engaged users to create stories and determine features. We did this back when you could with in-person interviews to understand the current experience, to create a data use profile. Are you a researcher? Are you looking for this in education? So on and so forth. We also used that POC, using data that they understood, to gain insight into their experience towards a new approach. And when you gain insight into the new approach, you also gain insight into how are they going to use the data, how do they think, and maybe where OOINet may not have met their needs. We took that information back, distilled it into features and functions, and started to develop. And we worked until we had a beta version of the product you see today. But then we re-engaged those interviewees to get feedback. Did we get it right? Did we hit the mark? And where we didn't, can we correct it? Again, we digested that, and the changes that could be made for version 1 release, we did, and those that we couldn't, we put on a roadmap, and typically it was effort driven that decided that. We then opened up the production URL 4 weeks early and let those same folks go in and take another look at it, more with the eye towards, yes, this is right, or no, the data is wrong, or this isn't working properly. We want to continue this user-driven design and community engagement. So this is a feedback loop. You'll see that we'll build POCs within Data Explorer. We will look to interview users and gain a stronger connection. We're going to stand up some social media platforms like Discourse, where people can discuss the features, the data, and I'm also going to look for a more formal method of engaging the users in users in the future, maybe through a user group out there. So I definitely want to hear about that. But you will notice when Craig does the demo that we have a very big feedback button. Please use it. We definitely want to hear from you. So what are some of the differences? The first difference, which is a definitely different approach for OOI, is the data sets are pre-calculated. This means that you can see a lot more data, a lot quicker, and in a very varied way than you might on OOINet. We've also merged streams, for example, telemetry and recovered. In OOINet, you'd have to look at both streams separately. Well, now they're together. So you have less decision-making, but yet you still get to see the same data. It's built on top of ERDAP, so you get all the benefits of the ERDAP server and the API that it brings. And if you're not familiar with ERDAP, there's a definition at the bottom of the slide. I think one of the strongest features of this is the ability to create custom data views and share them. And that's what Craig is going to show you. You also have the ability to view multiple graphs at once. Truly, if you want to, you can see every data point on a scrollable grid out there, which makes searching it much more intuitive, leading to robust search capabilities. We've also been working quite a bit on our CF compliancy in both naming and of metadata and how we build our net CDFs. But this project has really forced us to take it one step further. So you'll see a great improvement there. Before we move into the demo, I do want to cite that this is version 1.0. So we will move from here and we'll move up. Not all data is in there yet, and certain features still need, will get more robust as time goes on. So during this period, both Data Explorer as a data exploration tool will be available, as well as the traditional OOI net. With that, I will hand it over to Craig.
Craig, I made you host.
Okay, so hopefully you can see my presentation. Yep. Okay, great. Thanks, Jeff. So my name is Craig Rizian. I'm a faculty research assistant here at Oregon State University. I've been working for the OOI since 2010, mostly on the endurance array as a mooring technician, and I'm involved in the data team. And more recently, I became involved with the new OOI team, OSU OOI team that's transitioning the cyber infrastructure from Rutgers to OSU. Today, I want to talk, as Jeff has sort of introduced here, about the Data Explorer. It's a tool built by Axiom, so more specifically, Jessica Austin and Brian Stone, they're on the line here, and Jim Case has also been very involved in this effort. I'm going to show off some of the capabilities by building a data view that shows some seasonal hypoxia that occurred in August of this year on the Washington coast, and a wind reversal event that occurred kind of mid to late August that flushed the system. And so we'll walk through that and go through the functionality. Before we get there, I just want to kind of set the scene and provide a little bit of background and context. So the Coastal Endurance Array is an array that extends off the coasts of Oregon and Washington. You can see my cursor here. So we've got the Oregon line down here of Newport and the Washington line off Grace Harbor. Each of these lines consists of 3 sites. So there's an inshore site, a kind of mid-shelf site, and an offshore site. And we have these additional glider lines that run in between these moorings and offshore that provide additional coverage of the region. Try to get this out of the way. The Washington line is shown here on the right-hand side, and you can see the inshore site, the shelf site, and the offshore sites. Each of these sites has a mooring with a surface expression on it. The inshore sites here, it has a small submersible buoy, so it's able to withstand all the winds and waves that we experience here in the Northwest in the wintertime, and it has a limited sensor package on it. The offshore sites here, the shelf and the far offshore, those have much bigger buoys and they have a full MET package and all sorts of other sensors on them. Associated with these moorings are profiling systems. So those are inshore, and at the mid-shelf, these surface piercing profilers, and we'll see a little bit of data from those systems here shortly. And at the offshore site, there's a wire following profiler, which has McLean profiler on it. And as you can see, the sensor packages tend to be installed at the surface, near surface at 7 meters, and then at the sea floor. And we've got an incredibly wide variety of sensors and collecting all sorts of different data sets, from CTDs, oxygen, to velocity sensors, to bioacoustic sonars, or the MET variables that you could wish for, et cetera, et cetera. So just like I said, I want to show off some hypoxic, an event, a hypoxic event that occurred in August of this year. And so in the Northern California current upwelling system, we do see the seasonal hypoxia. Basically what happens is that we have these equated winds in the summertime, and this drives the upwelling of low dissolved oxygen water from just above this region here at about 150, 200 meters. So it's low DO, nutrient-rich water that comes up onto the shelf. And what we see in the summertime, as this nutrient-rich water gets upwelled, these phytoplankton blooms, and what's driving that is increased stratification of the water column, increased light availability, and obviously this availability of nutrient-rich water. So as these blooms die off, the respiration of this organic matter actually consumes oxygen, and so it will lower dissolved oxygen concentrations, and that's why we see this, this hypoxia in the summertime. The system is changing, and what I'm showing here is some data from a Chan et al. 2008 science paper on the right-hand side. And what you can see are thousands and thousands of observations taken along the Oregon coast between 1950 and 1999 in blue here. And the red line here shows that hypoxic threshold. What you see is that in the deeper part of the water column, the oxygen levels tend to be quite low, but here between 100 and the surface, 100 meters in the surface, well, back then we saw pretty oxygenated water. We very rarely saw the values drop below this threshold. That started to change in 2000, between 2005, where in green here you see these observations regularly falling in the surface waters, regularly falling below this hypoxia threshold, this red line. And in 2006, it changed even more dramatically, where we actually were measuring anoxic water, zero oxygen in the water column off the coast of Oregon. And this obviously resulted in huge die-offs of marine organisms, so dead crabs, the disruption of these rocky reef habitats. And now, 13, 14 years later, we actually see this regional hypoxia seasonally, so it's really become kind of like our wildfire season in the summertime. So the endurance array is really designed to observe these kind of changes. It's going to be out there for a long, long time, so we can start to better understand the timescales, and it also can observe these changes in sort of offshore, cross-shelf and along-shelf spaces. So today I'm going to focus, as we demonstrate the Data Explorer, on these two moorings. So this is the Washington Inshore mooring and the Washington Shelf mooring here, listed as number 5. And I'm going to show some hypoxic observations from August 2020. So I'm going to share my browser here. So hopefully you can now see my browser. And I'm going to have to move stuff out of the way here. All right, so this is the new Data Explorer. And I encourage you to follow along, dataexplorer.oceanobservatories.org, or just bookmark the page and come back to it later. There are a number of ways to enter this website. One way is to simply click the Data Access button, which is just going to drop us down. You can also just scroll down to this globe that shows all of the OOI arrays. And we have arrays that Jeff showed, here in the Pacific Northwest, the Regional Cabled Array and the Endurance Array. We also have Station Papa, which is in the Gulf of Alaska. It's considered a global array. East Coast has the Pioneer Array, labeled here and shown in yellow, Erminger off Greenland, and the 2 Southern Ocean arrays. which were discontinued a little while ago, but those data are still available through the portals. Today, we're going to focus on the endurance array. And so if you click on the endurance array, it'll highlight as the red button there. You can also select it on the map. You can select from various platforms that you might be interested in, whether you're interested in gliders or moorings or profilers. All of our instrumentation is listed here, as well as the many parameters that variables that we collect. I'm going to simply leave all of these as all and click this go button to show a listing of all of the moorings, profiling systems in the gliders in the endurance array. And in this list here, and as you can see, as this kind of scroll down this list up and down, you can see that yellow circle highlighting the particular site that I'm hovering over. You can do it on the map to zoom in on the map if you want. Today, I just want to start with the Washington inshore surface mooring. So that's highlighted in yellow here, and clicking on that will take us to this web page where you can see, we call them nodes. Basically, they're different instrument platforms that this mooring contains. There are these buttons up here, and so if you click on any of them, you will gain more information about this particular mooring. So here you can see the central mooring. It's, like I said before, this kind of small submersible buoy, so it's able to go underwater during our big storms in the wintertime. Has the 7-meter platform here called an NSIF, a near surface instrument frame, which has a whole host of different sensors on it. And at the seafloor, we have what's called a multifunction node that acts as an anchor, as well as a platform that we can bolt sensors to. So it has a similar wide variety of instruments bolted to it. Going back to this overview tab, what we're interested in really are the waters at the bottom. And so I'm going to click on this multifunction node, the seafloor platform. And it's going to take me to this website, or this web page that shows all of the different instrumentation parameters that one can find on this particular platform. And so clicking on the button here, I want to look at the oxygen concentration first off, and so we can bring it up here. This is a little small, so if I click on this button, this link here, I'll blow it up to a full screen. So this is where you can really start to explore these data. There's a way to expand to the full range. This is pretty limited time series that you're looking at right here now, but if I click this gray button, it will expand to the full time series and going all the way back to 2014 here, October 2014. And you're able to zoom in time using the slider bar at the bottom, which can move around like this. You can also zoom in by clicking on the time series here and kind of highlighting the area that you're interested in, and it will zoom to that particular time period. You can change how the data are binned. Right now, they're being binned kind of at a daily time scale, but I could change that to be hourly, and you can see how it changes, or weekly, like that. So I'm going to stick with daily for the moment. And what we're going to do now is start to build up a data view. So this is a way to take time series from different moorings, from different sensors, different variables, and add them to one web page so that you can kind of better understand the story of what's being presented here. So I'm going to create a new data view, make this thing, hit enter, and I'm going to add this time series that we're looking at right here to this, this new data view that I've called webinar. I also, because at the beginning of this, I mentioned that I want to look at a downwelling event that occurred in August. What we expect to see with the downwelling event is not only an increase in oxygen in the waters at the bottom, but also an increase in temperature. So I want to go back to the Washington inshore surface mooring page, go back to the MFN here. This is the seafloor, and I'm going to select water temperature. So you can see it here. There are actually a couple different water temperature time series coming off this thing. What I'm interested in is this first time series. So again, clicking on it, you can see it shown here, and I'm going to again show you the full time series. There it is. And one thing I wanted to point out in this particular plot is that we're now able to visualize quartile results. So this is something the OOI data team has been working on a lot in the recent months. And so you can see here in these green bars that we've applied some quartile tests to these data, and according to the color here, they have passed those tests. I also wanted to point out before going on that I can add these to these data to a data queue. And so on all of these web pages, you'll see these green buttons down here, which take you to this download panel, and it allows you to not only add the data to a download queue that you can come back to. It's up here at the top here a little later, or you can just download it directly by clicking on these buttons here. So I'll just go ahead and add that to the queue just for the moment, and close that window. I'm going to add this view, this time series to our data view by clicking this blue button over here, and you can see webinar. We've got one time series in there, and now we have two time series. I'm going to add the go back here to the first web page we were looking at that shows all of our moorings. I'm going to go to the Washington Shelf surface mooring. So that's highlighted in yellow here because that's got our Met data on it that we're interested in, because I'm interested in the north-south winds to see that reversal. Typically with an upwelling event, you see those equatorward winds driving that upwelling, but then when a reversal occurs, you'll see the winds switch, those north-south winds, to be positive, i.e. poleward. All right, so clicking on that mooring and the surface buoy, which is obviously where our Met package is located, we can see a whole long list here as I scroll down of all these different Met variables that we're collecting. And up here, you can see on the surface buoy that we're collecting, we've got a motion pack there, so we've got some wave information there. We've got different hydrogen sensors, PCO2A, and the wave spectra, point velocity measurements. But today, really, we're interested in the Met package, so I'm going to click on that. And again, there's a whole long list of variables associated with our Met package. What I'm really interested in are the northward winds at the bottom here, and they're shown here. So this time series obviously looks a little weird, and what's driving that is this period of bad data where apparently we have 7.5 million meters per second winds. So we've got some bad data that are in here. They're easily visible at least. Setting that aside for the moment, I'm going to blow it up here and show the winds. These are the recent winds. So this is kind of the most recent week to 10 days of winds. What we're interested in really is in August. So again, you can use the slider bar down here and extend the time series to a wider time range. And as I mouse over here, you can see the values changed, and what we're really interested in is August. So just drag here, zoom in on this period, add it to our data view that we're building. And again, I can change this to be hourly data or weekly, but I think what we're really looking for here is the hourly data. And in particular, it's this period here, right around August 20. Finally, we have these surface piercing profilers located at the inshore sites, both off Oregon and Washington, but also at the mid-shelf sites. And today I want to look at the Washington inshore surface piercing profiler shown here. So I can just click on this button and quickly jump to that mooring. You can see it highlighted here in, off the coast of Grace Harbor. If I click on the surface piercing profiler, and again, there's more information here. If I just click on this more information button, for example, you can actually see what this thing looks like. It has an anchor. It has this profiling package shown here with a whole multitude of sensors on it. And close that. It is actually able to break profiles from 5 to 10 meters up above the seafloor, up through the AC interface, and then telemeters the data to shore from there. And clicking on that node, you can see that we do still have some data to load in the system. You can access these data by the current OOI net. So if you click on here, it'll take you to OOI net. And these data will be loaded over the coming months as we build out this data explorer. Today, you can see that we do have these conductivity data. We do have data sets in here, and today we're really going to go some nitrates there, down to the dissolved oxygen data sets. Oops, PAR. This one. That's our level 2. We have various levels. The other one was at level 2, level 1. This is a corrected data product and oxygen data product. And so here are the profiler data collected from that inshore site. This is a curtain plot now, not a time series, and we can actually change the depth that we're interested in, and just like that time series slider bar, and slide this around, or you can look at the full depth. Again, you can grab the plot and drag and kind of zoom in on your period of interest, or click this expand bounds button up here and quickly get back to the full data set. We're going to be looking at the summer 2020 data. So zooming in here, you can see right around here in August, you can see low oxygen values at the bottom here. We're looking at about 40 micromole per kilogram. And again, you can change this to bin slightly differently. It's a little easier to see if we bin it by days. So I'm going to keep it as days. And I'm going to go ahead and add this to our final time series to our data view. All right, so we have 4 time series in the data view now, and I can get to that either by clicking right here on webinar. It should also be available up here at the top. Here, I can get it to that way too. All right, so this is our data view that we built. You can edit it. So if we don't like the title, I can click on that gearbox and change the title, and I can add a description down here. I can also delete it. We won't do that right now, but I'll update it and you can see it changes. You can share this data view by clicking at the top here and getting a permanent link, which you can share with friends, colleagues, whoever. And as Jeff mentioned, there's a feedback button here that we definitely encourage you to use, and send us your feedback, thoughts, suggestions that you have. That would certainly be appreciated. All right, so back to the data view that we built. You can see the surface piercing profiler data here and the time series that we added. These are the north-south meridional winds from the shelf mooring. What I'm going to do is I'm going to add the time series data to this comparison chart over here on the left. So I do that by clicking this button over here. So it's added it to this chart now. And I can do that for water temperature, and I can do it for the dissolved oxygen from that multifunction node from the bottom, from the seafloor there. So those data are now all added to this comparison chart, and you can actually start to compare them if you mouse over. side by side. I want to really zoom in on this period of interest, and to do that, I'm going to click on this, this calendar button here and select August 1st through September 1st. Apply this custom range, and I'm going to make the winds slightly different, make it a little bit more obvious, and keep the temperature and the dissolved oxygen as binned by days, which I think is easier to tell the story here. All right, so what we're showing in green are these north-south winds. Here's the zero line. It's hard. But you can see right around here, right around the August 2020, that you've got positive. So these are these downwelling winds, these poleward winds that are going to drive offshore water onshore and flush the system with relatively warm water that's relatively high in oxygen. And that's exactly what happens. So before that, when we've got these periods of upwelling, so these are equator winds, you have these very, very low temperatures, very low dissolved oxygen levels, shown here in kind of this orangey and purple colors. When you see this reversal here, mid to late August, a day and a half later, and you would expect that kind of delay. The winds change and the ocean takes a little bit of time to respond. So a day and a half later, you actually see this increase in oxygen and increase in temperatures at depth at roughly 28-ish meters, which is exactly what we would expect. Shortly thereafter, August 23-ish, so 3-4 days later, the winds become equatorward again, so upwelling favorable, and the whole system reverts back to this hypoxic kind of cold hypoxic regime, if you will. And that's it. On the comparison chart, I did want to point out that those download buttons are available here too. So again, you can click on these buttons. You can see them associated with each one of these time series. If I click on one of these buttons, it'll take me to an OOI page. Hopefully you're familiar with OOI. It is a fantastic tool for subsetting data. I was able to use the time sliders to get exactly the time period you're interested in. If you're looking at glider data, for example, you can create bounding boxes using these lat long sliders. You can pick from the list of variables available exactly what you want to download. And the other great thing about OOI is that it has an amazing number of file formats that you can choose from. So, whatever your favorite file format is, OOI has it pretty much, and you can download a mat file, hit submit, and those data will download. So you can build, your own data view in Python or in MATLAB or in whatever it is you want. So that's it. I guess one final thought I should point out. So don't forget the feedback. Don't forget to share these kind of data views if you want to share with colleagues, and you can get feedback on what others think about your data view. I did want to point out this downloads page again. Right now we only added one data set, but I could go and add, if I went to Pioneer, I could add some Pioneer data, just add, let's say, some Pioneer from this mooring, and you'll see so add it to the queue here. So now I've got a couple of different data sets. So it's very, very easy to flip from Endurance, just going to this access array data button up here. It was really, really easy to flip from Endurance over here to Pioneer, grab some central surface mooring bulk met data. These are wind data, add it to my downloads queue, which is this button down here. And then these data are now available in my queue, and I can come back at a later date and download whatever it is I'm looking at. there was one other thing that I did not point out, and that is the buttons underneath these time series. So what we try to do is annotate our data. If we have holes in the data because we had a system failure or something, or if there was some biofiling, we do try to annotate the data. And those annotations are shown in these plots. I don't. So here is one note, something about the pressure sensor occasionally dropping out. So that's under this annotations button here. And we do have information about the provenance. If I zoom out to the full data record, you can start to see the different deployments here shown, visualized here. So this is this deployments button. This would be one deployment, this would be another deployment of this particular buoy. The individual lines here indicate the different data streams coming off of this mooring. So we do have these recovered hosts, recovered instruments, telemetry data streams. And so that's why you see these individual gray lines, but taken as a group, you can see when this particular mooring was deployed based on this timeline shown here. So I think I covered a little bit of what this new Data Explorer has to offer. It's an incredibly rich tool. There's a lot more to see and do with it, as you explore these different arrays, these different platforms, different data sets. So we certainly encourage you to do just that. And please send us feedback via the button. Any questions, comments, concerns you have, we're happy to address them and talk more with you about your experience. Thanks.
Thank you, Craig and Jeff. I would invite all of our panelists, Stacy Buckaloo and Brian Stone, to also show us your faces, so you might be available to answer questions.
Yeah, it looks like a couple of questions were already asked in the Q&A panel. Craig, if you want to continue driving, I could try to answer, or I could share screen and try to answer. Either way is fine.
Why don't you, I'll stop sharing. Why don't you,
okay.
you drive?
Okay. Yeah, I always learn something when Craig uses the tool. So that was really cool. Thank you. Oops, I do not have the ability to share screen.
Craig, you have to make Brian the host.
Right. Maybe I should drive.
Okay.
I host you. Yes, you are now the host, Brian.
Okay. Yeah, I am trying to, there we go. All right, and I'll zoom in on it a little bit. Okay, does that look okay? Okay, so the first question was, if I'm not familiar with the array instrument assets, do I have to know which mooring has the met data, or can I search for wind data and be told where it is? And yes, there's a couple different ways to do that. So this little data access widget, which is accessible from the header or on the front page by clicking on data access, and this is exactly what Craig used. I could skip this, I could skip picking an array, and I could jump straight to instrument types. So for instance, if I was just interested in CTD, or I'll pick something a little bit more exotic. If I pick, let's see, yeah, dissolved oxygen. The arrays where it's not available, so it does look like it's available on all arrays. I can't think of a thing that's not available on all arrays right now, but those will minimize, and those wouldn't be selectable. So as I switch between instrument types, if you look at parameters, platform types, and the array list, those all update with what is available. So this is a way to sort of explore by instrument type or by parameter. So let's say I'm interested in chlorophyll A, everything updated, and then I can hit go, and I'll go to a page that offers all chlorophyll A data throughout the whole system. As I explore this data, it's telling me where in the system it is. So as I hover over this first plot, you can see that the yellow dot on the map is highlighted, and the depth plot shows where within the water column that data is collected. The second question was, can you explain seasonal statistics? Are these climatologies? So these are, we don't call them official climatologies. These are seasonal statistics based on the data available. So we take all data that has passed quality control if quality control is available, so quartile. And then we take the mean, min, max, and 10th and 90th percentiles for each bin available. So this is a better way to look at it. And I'll just say, you can also come down here and hover over each of these elements. So seasonal statistics are sort of spelled out in the legend here. But the pink area is the seasonal mean to 90th percentile. The light blue area is mean to 10th percentile. The red dotted line is the all-time high for that bin. And the dotted blue line is the all-time low. Craig, I don't know if you had anything to add there.
Nope.
Okay. When we calculate those seasonal statistics, you also sort of for free get these other charts. So you could look at anomaly plots, and we could ratchet those down to days, or you could look at sort of this traditional annual average plot. And this is a year-over-year plot. So right now we're looking at 2020 against the other averages. And, you can go through the years. These can all be added to data views just like Craig did. And then I think, so there was another question. If I choose daily wins versus hourly wins in the plot, does that translate to the data download, or do the data always come back at their native resolution? There's a few different answers to that. And Jess, feel free to pipe in if you have something to add. So when you choose a bin period and you hit the download button, at the bottom, there's this calculated data area. And so in this case, and that's going to give you what you see on screen. So in this case, there's too much data for us to offer that download from this interface. But if I were to pick a coarser bin size and then open this guy, yeah. So now I can download binned weeks. And so that's going to give me exactly the same data I'm seeing on screen. If I go to ERDAP, I am going to get a combined time series, a combined time series across all deployments. And that is right now, the highest resolution data we're offering is by minute. And so that's an easy way to get the full time series for this particular instrument, but you're not necessarily going to get the highest resolution available. If you want to explore if higher resolution data is available, you need to go to all downloads. And then from here, you get a table of each deployment and its raw data download. And so from there, you can get to a thread server or an ERDAP server where you can explore that high, super high resolution data. And that is the actual raw data. M2M is still available on OOI net. Recently, there was an issue with glider positions where positions were calculated via dead reckoning, which, as I understand it, was a temporary condition. Is there a flag for data that has issues like this in the interface? So we didn't actually go over glider data. Glider data, we don't surface the same quality control metrics that we do for the other time series data. So I think that would be a question more for the OOI data folks.
That issue that Eli is referring to impacted OOI net, but there's a different, so this tool that you're looking at here gets glider data, OOI glider data from the glider DAC, and there's a different processing mechanism by which those glider data are packaged and shipped to the DAC. And my understanding is that the lat long position that Eli's referring to, that did not impact any data that was sent to the DAC. That was data. So if you had made an M2M request to OOINet, you would have encountered that issue. But Data Explorer that you're seeing here gets its data not from OOINet, but from the Glider DAC, where that was not a problem, not an issue. And so, you know, if you were to go to the DAC and download the Glider data, Pioneer data is there, endurance data are there, I think global data are there, you will not encounter that lat long problem. But I will say that that lat long issue has been resolved on OOINet 2 now.
Okay. And so I quickly browsed to some glider data just to show that how it's visualized in the system. This also has a downloads link. So yeah, this is data that's available.
Yeah, hopefully that answers your question, Eli. I'm not sure how to verify that, but
so this is, Craig, I might throw this question back to you. Is there a data handbook available, including a description of the instruments and how they measure data to compare with other conventional arrays like NDBC?
I guess the short answer is not that I'm aware of. I mean, if you're looking for a one-to-one comparison, so if you take, I'm just trying to think of an example. So if you take our data at the endurance array CEO2, which is the shelf site in Oregon, we asked, well, first of all, Pioneer and Endurance and Erminger are all sending our data to NDBC, so you can get OOI data from NDBC now. Our data tend to be at a higher resolution than NDBC data. Though NDBC is changing to higher resolutions, 10, 15 minutes, I think. Historically, it's been more like hourly, and we certainly have a higher temporal resolution associated with our data. And obviously we have many, 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 many more sensors than NDBC deploys on their moorings. So, you know, their focus is on primarily on met stuff and waves. Some of the moorings do have ADCPs and some of them have microcats. You know, we have just an incredible wealth of data on our moorings at higher temporal resolution and at more positions in the water column. NDBCs tend to be at that surface level, so we have all those data, but we also have the 7-meter NSIF, the near surface instrument frame, and we have the data on the sea floor. So I don't know of a document that does a one-to-one comparison, but I would say that we have a richer data set and a data set that is at a higher temporal resolution if I were to generally compare it with what NDBC serves at like 46050, for example. Hopefully that answers the question.
I think that we've answered most of the questions live that were asked in the panel.
I would point everyone to the chat room where someone had asked that they had missed the seasonal statistics, and Stacy Buckaloo responded and gives a detailed explanation on how to get the seasonal statistics.
Thanks, Darlene. Brian, could you also show the help documents? I put links to the help documents that are available from within the Data Explorer. And here we have sort of the how-to documents. In addition, you know, overview documents in addition to the how-to that show animations of how to do a lot of these features. So I was able to provide links to some of those questions that hopefully are a helpful resource as well.
Yeah, so this walks through some of the stuff that Craig looked at for adding. So this particular animation that we're looking at, this isn't me doing it. This is a sort of a small GIF that you can get to from the help docs. So this is a way, you know, if you're having trouble figuring out how to do something, this can be a way to go through that.
And there are 2 more questions in the Q&A.
Okay, if the data have quality flag, is that applied to only return valid data in a download, or do I have to apply that as a constraint in ERDAP? And Jess, I don't think you have, I don't think you can unmute, but I believe you need to, so the flags are in ERDAP, so you do need to apply that as a constraint. Okay, that's my understanding. Okay, good question. Can I create profile plots for profile moorings? So I can demonstrate that by going to all profiling assets. And so this gives me this grid view of all assets that are profiling. So from here, I can hover over these and get a single profile for the bin that I'm looking at. If I want to, dig deeper, I can enlarge and go to the full screen here. And again, I can use the sliders to change my time period of interest. I can use my depth slider to look at a particular area of the water column. Or if I see something of interest, I can just zoom in using mouse drag. And so we're at hourly data now. If I zoom in far enough, eventually I will get all data and you can see the individual profiles. So we're at 1 hour now, and so you can see here, the sky is stepping its way up. Okay, hopefully that answers your question, Kendra. From a teaching perspective, it might be difficult for students to find particular sensors that they're looking for when they are confronted with nodes. For endurance, this is rather straightforward, but at Axial, this is more confusing. If you look at a node view, it's hard to find exactly which data we want. And if we filter the parameters earlier, we get multiple sensors that give the parameter. If a student is exploring and they just want oxygen, is there an easy way to determine which sensor is best? So I can't speak to which sensor is best, but there are a couple of ways to sort of explore by parameter. So anytime you get to one of these grid views, so let's take the regional cabled array, I can choose to look by parameter. So I'm gonna do that by going to the overview page, and then along the top I get more information, which Craig looked at, nodes, which is kind of a OOI specific term, instrument types. So this, ADCP, CTD, dissolved oxygen, but I can also look at by parameter. And so here I can go down and find dissolved oxygen and look at just dissolved oxygen from the regional cabled array. If I'm interested in filtering by instrument type, I can then do that. And I'll just add to that, we're very interested in how this will and can be used in the classroom setting. And so if you're, putting together a lesson plan or, trying to figure out how your students are going to get in, we would love to hear your use case. You can use the feedback tab. So the nice thing about this feedback button is if you're on a page and you're confused about something, if you hit the feedback button while you're on that page, when we get your note, we're going to get a link to exactly what you're looking at. So it can just make that conversation easier. As far as sharing this kind of thing with students, if you were putting together a Google Doc or something with links, you could link directly to this view. So if I copy the URL out of my browser, I can then send it out and people will see exactly what I'm seeing. I can also use the share link. That's more useful if I've created a data view because those are specific to your user session.
We're at the top of the hour now. I would like to thank all of our panelists on behalf of OOI. You did a great job, and it's really a wonderful addition to how to retrieve and use OOI data. And I would encourage everyone, will have some more demos of Data Explorer during AGU, so visit our virtual booth there, and please use the feedback button because, as Jeff said, this is really a site that's under development to meet the needs of its users. So unless anyone has anything else, we're signing off. Thank you all for attending.
Thank you.
Thanks, everyone.
Bye-bye.
Bye.